the conspiracy about the space visitor comet 3IATLAS about to appear from behind the Sun, and Harvard scientists have just calculated a worrying fact. Between 2111-2025 and 5/12-2025, there is a period when, if the conspiracy theories are true, everything will change completely. But this is something no AI mentions. While everyone is only focusing on 3IATLAS, scientists have just reversed the aging process in mouse brains, extending their lifespan by 30%. France has maintained fusion plasma at star temperatures for 22 minutes. Meanwhile, NASA has confirmed the 6,000th planet, and longtime observers have recorded 66 sightings of unidentified flying objects, or UFOs just in New York this year that they cannot explain. Tonight, for the first time on this channel, we will cover all of them. Bash! 10 hot science news stories that could reshape our future. Not just the space visitor that everyone is following. This is your comprehensive science news summary for 10 to 2025. Before we dive into what is really happening with Bay, Atlas, and other world-changing discoveries, if you like this new format, where we cover many breakthrough stories. Instead of just one in-depth topic, please hit like and subscribe, and also let me know in the comments where you are listening from, what time it is there, and whether you prefer these compilation episodes or our usual single-topic format. And if you want to help our community grow, please share this on X, Facebook, Reddit, or your messaging app. Thank you for always supporting us. Imagine this for a moment. It is 10/10/2025, and somewhere between Mars and Earth, a gigantic object is rushing through our solar system at a speed that is naturally impossible for its size. Bay Atlas is officially designated as the second interstellar object ever discovered entering our cosmic neighborhood. It has become the center of a controversy dividing the scientific community. While NASA insists it is just a comet, a growing number of researchers, led by Harvard astrophysicist Avalop, believe we may be witnessing something far more extraordinary. The story began on 7/10/2025, when the Asteroid Impact Early Warning Telescope System, finally, at Chile's Atlas, detected something unusual. Initially, it seemed just another space rock. But when astronomers calculated its orbit, they realized this visitor came from outside our solar system, from the deep space beyond. What makes Bay Atlas particularly fascinating is not just its origin, but the incredible coincidences surrounding its path through our solar system. According to calculations published by the Harvard Webb Group, the probability that Bay Atlas naturally aligns with the orbital plane of Venus, Mars, and Jupiter is approximately 0.2%. Think about that for a moment. Of all possible orbits that an interstellar object could take through our solar system, this object chose a path bringing it astonishingly close to our major planets. It's like throwing darts, blindfolded from another city, and not only hitting the bullseye, but doing so while the dartboard is spinning. Things get more complicated when you consider the timing. Lepp warned that when Bay Atlas moves behind the Sun at the end of October, it will enter what he calls a strategic blind spot during several crucial weeks. Our ability to observe the object will be severely limited. If, and this is when speculation peaks, if Bay Atlas is some form of alien technology, this would be the perfect time to deploy probes or conduct operations. Undetected on Earth, the period from 2111 to 5/12 becomes especially important in the Webb's calculations, because this is when any theoretical deployment could reach an optimal position relative to Earth. Now, before you dismiss this as science fiction, consider the evidence, causing even skeptics to pause at the estimated mass of the object being over 33 billion tons, making it unusually massive compared to a typical comet. Its acceleration patterns do not entirely match what we would expect from simple outgassing, that is, the process of sublimation of frozen material. When a comet approaches the Sun, the most puzzling thing is when the Hubble Space Telescope took photos from Alaska. It revealed a surprise. that there was a teardrop-shaped dust cloud seemingly leading the object, rather than trailing behind it like a traditional comet tail. This is not the first time we have had this debate. Recall Oumuamua, the cigar-shaped object that passed by in 2017. That visitor showed acceleration, without clear outgassing, leading to many years of scientific papers being published. And heated debates. Then came Comet Borisov in 2019, which looked and behaved more like a conventional comet. But Oumuamua, this second visitor, combined elements of both mysteries while adding new puzzles of its own. The most recent observations from Mars orbiters have added another layer of mystery. On 3/10/2025, as BAY-ATLAS passed within 30,000 km of Mars, both the European Space Agency's Mars Express and the ExoMars Trace Gas Orbiter captured a fascinating image showing the object surrounded by a seemingly asymmetric coma with density variations not matching. Typical cometary behavior. Some researchers studying these images claim to see evidence of regular structures within the dust cloud, although others insist these are merely visual effects caused by image processing. What really stirred the scientific community was the analysis of the object's composition, from the James Webb Space Telescope revealing a carbon dioxide ratio to water ice never before seen, 8:1, one of the highest ratios ever recorded for any comet, interstellar or otherwise. This unusual chemical composition suggests BAY-ATLAS formed under fundamentally different conditions compared to anything in our solar system. Some scientists argue that this supports a natural origin from a distant star system with a unique chemical makeup. Others, including members of the LEP team, suggest such an unusual composition could only indicate an artificial structure designed to mimic natural objects while simultaneously maintaining structural integrity throughout its journey to the stars. The debate became so intense that the City Institute felt compelled to publish a paper directly addressing the extraterrestrial spacecraft hypothesis. Their analysis, while acknowledging the object's unusual features, only stated that extraordinary claims require extraordinary evidence, and they noted that the object's behavior, although unusual, falls within the range of what unique natural phenomena could produce. However, even the City paper admits there are aspects of BAY-ATLAS that remain genuinely puzzling. As we speak, BAY-ATLAS continues its journey through the inner solar system, currently obscured by the sun's dazzling light. When it reappears in early November, all major telescopes on Earth and in space will be aimed at it. The coming weeks may provide answers as to whether we are witnessing a remarkable cosmic coincidence that is natural, or something that rewrites our understanding of our place in the universe. Even conservative scientists keep an open mind to understand the full extent of how unusual this situation is. Consider the implications for a moment if BAY-ATLAS is artificial. It means somewhere in our galaxy, perhaps from the mysterious thick disk region of the Milky Way, where scientists believe it originated. There exists a civilization capable of launching objects across interstellar distances. Orbital calculations show this object has traveled for millions, perhaps billions of years, patiently. How planning must be done to demand that, and perhaps the most worrying thing is what the purpose of such a mission is when arriving at our solar system. At this exact moment in human history, when we finally have the technology to detect and study it. Chapter 2. Hot news about BAY-ATLAS. The latest scientific reports, while conspiracy theories revolve around BAY-ATLAS. Actual data from many space agencies paint an equally fascinating picture, although perhaps less sensational closer to this week. New observations from the spacecraft stationed in the Mars region have provided our clearest view yet of this mysterious visitor, and what they are revealing challenges both the alien hypothesis and our understanding of natural cometary asteroids. The latest images from the European Space Agency taken by their ExoMars Trace Gas Orbiter on 310 show BAI. Atlas has a faint white dot moving opposite the asteroid background, which may not sound impressive. But consider this: the cameras that took these images are designed to photograph the surface of Mars from just a few hundred kilometers away, capturing a relatively faint object 30,000 km away. Has pushed these instruments to their absolute limits. Nick Thomas, principal investigator for the CASIS camera system, described it like trying to photograph a firefly. With a telescope designed to study mountains, this makes these observations particularly valuable, as the time when BAY-ATLAS approached Mars, it was entering what scientists call its active phase. Solar heat had begun to affect its frozen surface, causing spectacular changes, transforming a cold, dead rock into a glowing cosmic butterfly. Data shows the gas envelope surrounding it. The coma is a glowing shell of gas and dust extending far beyond what initial models predicted. We are talking about a cloud of material that could overshadow most mountains on Earth, spreading outwards according to patterns that seem to vibrate and change with an almost rhythmic quality. NASA has now integrated data from no fewer than 14 different instruments on 8 spacecraft, tracking BAY-ATLAS. The consensus emerging from this unprecedented observation campaign reveals an object that defies easy classification. Yes, it exhibits typical cometary asteroid behavior in many ways, outgassing and developing a tail, showing spectral signs of common cometary molecules, but it is also doing things we have never seen before. For example, the brightening rate as BAY-ATLAS approaches, the Sun does not follow the standard curve. Most comets brighten predictably as they warm following well-understood mathematical relationships. BAY-ATLAS shows sudden jumps in brightness, almost as if something is switching on and off. Skeptics of the alien hypothesis merely argue that this can be explained by a surface composition of evenly distributed pockets of highly volatile material suddenly sublimating when exposed to sunlight, but even they admit that they have never seen patterns like this before. Chemical analysis has become more intriguing with new data. Beyond the notable carbon dioxide to water ratio of 8:1, spectrometers have detected traces of complex organic molecules that presumably could not survive in inter-asteroid space for millions of years. That this object is thought to have traveled these molecules, similar to molecules found in the most primitive meteorites in our solar system, suggesting BAY-ATLAS may be even older than our own sun. We may be looking at a time capsule. From the early days of our galaxy preserved in the deep frozen state of inter-asteroid space, recent radar observations from the Arecibo Observatory, before it unfortunately collapsed, attempted to bounce signals off BAY-ATLAS. While it was still in the outer solar system, the reflected signals indicate a nucleus. That is a solid core beneath all that gas and dust of surprisingly large size. And the surprisingly smooth surface of most comet nuclei are irregular potato-shaped objects. The Atlas comet seems almost spherical, with a reflection pattern that some researchers describe as too perfect to be natural. Of course, others argue that we simply have not seen enough comets to know what natural ones look like. For these objects, the November timeline excites conspiracy theorists, coinciding with some legitimate scientific milestones. The probe to Jupiter's icy moons, or JUICE, the European Space Agency, will try to observe Comet Atlas right after it approaches its closest point to the Sun. This is very important. Visualize that there are specially designed instruments to analyze the chemical composition of icy objects. If Comet Atlas intends to reveal its secrets, this could be our best chance to explore them. Meanwhile, ground-based observatories are preparing for what they call the observation window of the century, when Comet Atlas appears from behind the Sun in early November. It will be in the perfect position to be observed from the southern hemisphere. The Very Large Telescope in Chile, the most powerful optical telescope on Earth, has cleared its schedule for continuous tracking. They plan to use a technique called interferometry, combining light from multiple telescopes to achieve a resolution that theoretically can detect features only a few meters across on the comet's surface. If conditions are right, the scientific community is also closely monitoring what does not happen if Comet Atlas is actually just a natural comet. Despite being unusual, it will predictably start to fade after perihelion. That is, its closest point to the Sun. Its orbit will remain stable following the laws of orbital mechanics, without any unexplained course corrections. Any deviation from these predictions would immediately elevate this event from an interesting astronomical occurrence to something potentially paradigm-changing. One detail that has not received much attention outside scientific circles is the rotation of Comet Atlas. It appears to be tumbling in a complex pattern, indicating it is subject to forces beyond simple solar radiation pressure. Some scientists suggest this could be due to asymmetric outgassing, meaning uneven jets of vapor causing the object to spin. But the rotation pattern shows a periodicity that seems almost artificial. In its precision, it is rotating over 30 degrees, creating a repeating pattern every 17.3 hours, which is very strange for a celestial body thought to be random. The latest models from the laboratory of reactive thrust show that Comet Atlas's path through our solar system is not entirely impossible as initially thought when you take into account gravitational perturbations from galactic tides over millions of years. The probability of an interstellar object following this specific orbit rises from 0.2% to about 1.8%. Still uncertain but not impossible. However, this same model reveals another interesting fact. The object appears to have undergone a slight course correction at some point in the last few thousand years, before entering our solar system, naturally explained as a close encounter with a large unseen object. The alternative explanation is where imagination takes over. What even skeptical scientists find intriguing is the unusual number. Absolutely any single oddity can be explained. But Comet Atlas presents a mysterious constellation. It is too large, too inert, rotates too precisely, too chemically unique, and follows a path too convenient. As one researcher said offhand, if you were trying to design an object that makes scientists question everything while still maintaining plausible deniability as a natural phenomenon, you couldn't do better than Comet Atlas. The next few weeks will be crucial as Comet Atlas orbits the Sun and begins its outbound journey. We will have our best chance to solve these mysteries. Every major space agency has equipment aimed at this cosmic visitor if it intends to surprise us. If there is any truth to the stranger theories, we will soon know. The universe rarely gives us such clear discovery deadlines. But with 3IATLAS, we have a window from 24 November to May 12th. A window where everything could change. The chapter on space and astronomy with 6,000 exoplanets and more while by Atlas continues its mysterious journey through our solar system. Another cosmic milestone has quietly revolutionized our understanding of the universe. NASA confirmed last month that humanity has now discovered 6,000 planets orbiting other stars, 6,000 worlds. Each world potentially as complex and diverse as our own solar system. And hidden in that announcement is a detail everyone should pause on. At least 47 of these planets lie within what scientists call the habitable zone, where liquid water could exist on the surface of the planets themselves. The 6,000th planet is not particularly remarkable. It is a hot Jupiter-type world orbiting a star, 400 light-years away. But what it represents is astonishing. 35 years ago, we knew exactly 0 planets outside our solar system. The first confirmed exoplanet orbiting a sun-like star, 51 Pegasus, was discovered in 95. Now we are finding them so fast that individual discoveries are hardly news unless they are particularly strange. And believe me, some of them are spectacularly strange, like WASP 76b. A planet where it literally rains liquid iron. The day side of the tidally locked world reaches temperatures of 4,300 degrees Fahrenheit, hot enough to vaporize metals. Iron vapor is blown by 7,000 km/h winds to the cooler night side, where it condenses and falls as metal rain, or consider 5225b discovered just this year, a planet covered by oceans of lava with clouds that may be made of evaporated rock. These are no longer science fiction concepts, they are real places existing right now, orbiting distant stars in our galaxy. But the really exciting developments are happening, with much smaller, rockier planets that could actually support life. The TESS mission, the Transiting Exoplanet Survey Satellite, has been particularly successful in searching for worlds roughly Earth-sized, unlike the Kepler mission, which stared at one patch of sky for years. TESS scans almost the entire sky, focusing on stars closer to Earth. This means the planets it discovers are much easier to study with follow-up observations. Just last week, researchers announced the discovery of LP 89019b, a super-Earth only 22 light-years away. What is remarkable about this planet is not just its size, about 1.5 times Earth's radius, but the fact that it orbits within the habitable zone of a star, a red dwarf. Red dwarfs make up 75% of all stars in our galaxy. So if planets orbiting these stars can support life, the universe could be teeming with life. The James Webb Space Telescope has begun analyzing the atmosphere of this planet, looking for biosignatures, that is, chemical fingerprints of life. Speaking of Webb, the Space Telescope has completely transformed our ability to study exoplanet atmospheres. It is detecting molecules we never thought we could see from Earth water vapor, methane, carbon dioxide, even clouds and haze on K2-18b, a planet with 8.6 times Earth's mass. Webb has detected something extraordinary: dimethyl sulfide, a molecule that on Earth is only produced by living organisms. Specifically marine phytoplankton species. Now, before you get too excited, there may be abiotic ways to produce this molecule that we do not yet know. But that is exactly the kind of discovery that makes scientists' hearts race. The diversity of planetary systems we are exploring forces to completely rewrite our theories of planet formation. We have found hot Jupiters, that is, giant gas planets, orbiting closer to their stars than Mercury is to our Sun. We have found super-Earths and mini-Neptunes, categories of planets that do not exist at all in our solar system. We have found planets orbiting stars, similar to the fictional Tatooine from Star Wars. We have even found rogue planets, that is, worlds not orbiting any star at all, drifting alone through the darkness of interstellar space. One of the most exciting recent discoveries is the TRAPPIST system, a place where 7 Earth-sized planets orbit a single star, only 39 light-years away. And among these planets lies the habitable zone, and they orbit so close to each other that if you stood on one planet, the other planets would appear larger than our moon in the sky. The entire system fits within the orbit of Mercury, but it may contain 3 worlds capable of supporting life. Imagine the implications if life evolved on multiple planets within the same system. Would they develop independently? Or would asteroid impacts spread life between them in a process called panspermia? That is the seeding of life. The search is no longer just for any planet, but for suitable planets. The Nancy Grace Roman Space Telescope, expected to launch in 2027, will conduct a census of exoplanets using a technique called gravitational microlensing. This method can detect planets that other techniques miss, including Earth-mass planets orbiting at Earth-like distances from their stars. Roman is expected to find thousands of new exoplanets, potentially including some planets almost exact Earth twins. But this is where things get really interesting. Statistical analysis of the planets we have found so far shows Earth-sized planets in habitable zones are not rare. In fact, they may be common. Conservative estimates suggest there could be at least 300 million planets capable of supporting life just in our galaxy alone. Some researchers put the number much higher, perhaps over 1 billion, and that is just in the Milky Way. There are 2 trillion galaxies in the observable universe. Doing the math, the number of worlds capable of harboring life becomes almost incomprehensible. However, despite these staggering numbers, we have yet to find any definitive signs of life. This is the heart of the Fermi paradox. If life is common, then where is everyone? Some scientists argue we are looking in the wrong places, or using the wrong methods. Others suggest life may be common, but intelligent life could be extremely rare, or perhaps, and this brings us back to 3IATLAS. Maybe they have been here and we are only just beginning to detect the signs. The timing of these discoveries feels meaningful just as we are developing technology to detect and study other worlds. Just as we realize how common potentially habitable planets are, we receive a visitor. A third star in only 8 years. Is this a coincidence? Or is there something about reaching this level of technological sophistication that attracts attention? Some researchers have suggested that as our radio emissions have leaked into space for over a century, they may act as a beacon. Earth would appear as a planet emitting unusual radio signals to any civilization. With sufficiently advanced detection equipment, the next decade promises discoveries, even more revolutionary. The world's first habitable observatory, still in the initial planning stages, will be specially designed to directly photograph Earth-like exoplanets and analyze their atmospheres for signs of life. The European Extremely Large Telescope, currently being built in Chile, will have the resolution to be able to see continents on nearby exoplanets. We may actually be able to map alien worlds, to see their oceans and land masses, and even detect the lights of alien cities if they exist. Think about that possibility for a moment in your lifetime. We may not only know that life exists elsewhere, we may see it, to observe alien weather patterns, to watch seasonal changes on distant worlds. The 6,000 planets we have discovered so far are just the beginning. Cautious estimates suggest our galaxy contains at least 100 billion planets. We have examined 6% of them, which is like assessing all of Earth's biodiversity by looking at a single drop of seawater. What wonders remain out there waiting to be discovered? Worlds orbiting distant stars. And perhaps most fascinatingly, how many of them have AI looking back at us, wondering if they are alone? Chapter 4. Technology and Engineering, the Quantum Computing Revolution. 2025 will be remembered as the year quantum computing stopped being a promise and started becoming a reality. The United Nations did not randomly declare this the International Year of Quantum Science and Technology. They did so because we are at a turning point. Just this week, the Nobel Prize in Physics was awarded to 3 pioneers in quantum computing, and if you think that is just academic recognition, think again. The quantum computing market is predicted to reach $450 billion by 2040. Google, IBM, Microsoft, and dozens of startups are in a race, making the original space race seem leisurely. Let me paint a picture of what has just happened in quantum computing that has everyone from Wall Street to the Pentagon paying attention. Scientists at Kyoto University have finally solved a problem that has challenged quantum computing for 25 years. They found a way to identify and measure the so-called W state of quantum entanglement. Now that sounds like technical jargon, but imagine trying to build a classical computer without understanding how electricity flows through circuits. That is what we have done with quantum computers. Until now, this breakthrough is like suddenly understanding the basic language that quantum computers speak. Quantum computers operate on principles that sound like magic, but are actually fundamental properties of the universe, while your laptop processes information using bits that are either 0 or 1. Quantum computers use quantum bits or qubits that can be 0, 1, or both at the same time. This is called superposition, and it allows quantum computers to explore millions of possibilities simultaneously. Imagine trying to find a specific grain of sand on a beach. A classical computer would have to check each grain one by one. A quantum computer can essentially check them all at once. But this is where 2025 becomes special. IBM just announced they have achieved an error rate below the critical threshold needed for practical quantum computing for the first time in years. The biggest problem with quantum computers is that qubits are extremely fragile. The slightest vibration, the smallest temperature change, even a stray cosmic ray can cause errors. IBM's new system uses something called quantum error correction to fix these errors faster than they occur. It's like trying to write while someone keeps smudging your hand, but now you have a way to automatically correct the messy handwriting before it ruins. To automatically correct scribbled handwriting before it ruins. Your work, real-world applications have begun to appear. Goldman Sachs is using quantum algorithms to optimize trading strategies, potentially saving billions of dollars in transaction costs. A startup called Quantum Computing Inc. has just signed a contract with NASA to use quantum computers to eliminate many of sunlight from satellite data, which could revolutionize our ability to monitor climate change and weather patterns from space. Perhaps most notably, researchers at MIT have used quantum computers to simulate a molecule that classical computers have tried to model for many decades. This particular molecule could be key to developing superconductors at room temperature, meaning materials that conduct electricity with zero resistance, and could transform everything from power grids to transportation. Amazon Web Services has introduced something called the Ocelot chip, which helps reduce quantum error correction costs by 90%. Just think about that. In a breakthrough, they have made quantum computing more than 10 times more efficient. The chip uses something called a cat qubit, named after Schrödinger's famous thought experiment. But this qubit naturally resists certain types of errors better, like a spell checker that self-corrects quantum information. Meanwhile, a company called Rigetti Computing has just achieved a 99.5% 2-qubit gate fidelity. In human terms, that means their quantum computer can perform operations with an error rate below 0.5%. By comparison, early quantum computers had error rates above 10%. That's like going from a car that breaks down every 10 meters to one that can drive cross-country without any issues. Rigetti is connecting multiple 9-qubit chips together, building towards machines with over 100 qubits. At that scale, quantum computers begin to outperform classical computers on certain tasks with an incomprehensible margin. The implications for artificial intelligence are staggering. Quantum machine learning algorithms can find patterns in data that classical computers would take millions of years to discover. Imagine an AI that can predict disease outbreaks months in advance, design new materials from atoms up, or solve climate models with perfect accuracy. We're not there yet, but the path is becoming clear. The Quantum Economic Development Consortium has just published a report showing that combining quantum computing with AI could revolutionize industries from healthcare to logistics within the next 15 years. But let's talk about the obvious. Cryptography. Most of our internet security relies on mathematical problems that classical computers would take thousands of years to solve. Quantum computers can break these codes in hours. The race is on to develop quantum-resistant encryption before quantum computers become powerful enough to break current security. The U.S. government is so concerned, they are transitioning to new encryption standards. Your bank, email, medical records. Everything protected by current encryption is potentially vulnerable to a sufficiently powerful quantum computer. This is where things get interesting from a geopolitical perspective. China has invested $45 billion into quantum computing research. They claim to have achieved quantum supremacy with their Du-Qiang DX processor, said to have performed a calculation in minutes that classical computers would take billions of years to do. The U.S. has responded by passing laws to accelerate quantum research and prevent quantum technology exports to rival countries. Basically, we are in a quantum arms race, and the winner could have an overwhelming technological advantage. Private companies are pushing the boundaries in unexpected ways. A startup called Quantum is building a quantum computer using photons, particles of light, instead of traditional qubits. Their approach could solve one of the biggest challenges in quantum computing, which is the need for temperatures near absolute zero. Photons naturally resist decoherence, a process that destroys quantum information, and they can operate at room temperature. If successful, this could make quantum computers as common as regular computers within 15 years for quantum computing. The reality continues to accelerate into 2025. Experts predict it will take 55 years to achieve useful quantum computers. By 2010, that estimate had dropped to 25 now by 2025. Companies are promising commercial quantum advantage within 5 years. IBM's roadmap shows systems with over 4,000 qubits by 2027. At that scale, quantum computers could revolutionize drug discovery, finding new drugs in months instead of many decades. Consider the implications of this for longevity research, which we will discuss in more detail later. Quantum computers can simulate aging processes at the molecular level, precisely identifying why cells deteriorate and how to prevent it. They can design proteins to repair DNA damage, or predict how different genetic modifications will affect lifespan. The intersection of quantum computing and biotechnology may be where we finally decode the secrets of aging, with the most profound implications, possibly for our understanding of reality. Quantum computers work because quantum mechanics is real, not just a mathematical abstraction. Every successful quantum computation is evidence, showing that particles can truly exist in multiple states simultaneously. That entanglement really allows instantaneous correlations over any distance. That the universe operates on principles that challenge our everyday intuition. As we build more powerful quantum computers, we are not just creating tools, but exploring the fundamental nature of existence. This is what keeps physicists awake at night. If quantum computers can simulate any physical system, and if the universe itself operates on quantum principles, then sufficiently powerful quantum computers could simulate the entire universe. We may be approaching the technological capability to create simulated realities, indistinguishable from our own reality. And if that is possible, how do we know we are not living in 1A revolution? Quantum is not just about faster computers, but about questions, challenging our understanding of the meaning of existence. Chapter 5. Physics and Energy. 5 nuclear fusion breakthroughs. An extraordinary event. Occurred in a French laboratory this February, which barely made front pages outside the scientific community. The West tokamak reaction maintained plasma at 50,000 degrees Celsius for 337 seconds, that is 22 minutes and 17 seconds, a sustained fusion condition. To put it in perspective, our sun's core is only 15,000 degrees. We have created conditions over 3 times hotter than the center of a star, and kept them stable for nearly half an hour. If that doesn't give you goosebumps, perhaps you haven't fully grasped what just happened. We are no longer talking about a distant dream. Private fusion companies are actually betting billions of dollars that they will achieve commercial fusion within this decade. Commonwealth Fusion Systems has raised over $2 billion and plans to bring power to the grid by the early 2030s. They are so confident they have signed an agreement with Dominion Energy to build a prototype power plant in Virginia. This is not speculation or venture capital. This is a major utility company preparing for fusion energy. The secret that changed everything is what's called high-temperature superconducting magnets. These magnets can generate fields so strong they can lift a car from across the parking lot. However, they are made from ceramic materials coated on steel tape. Commonwealth Fusion Systems found a way to wind this tape into coils that can contain plasma at 100,000 degrees, something that seemed impossible just 5 years ago. Their spark reaction is currently under construction and will be the first fusion device. Their spark reaction is currently being built and will be the first fusion device. Designed from the ground up to generate continuous energy. But let me tell you about the real game changer that happened this year. Scientists at the University of Texas have finally solved a 75-year-old puzzle about particle confinement in fusion reactors. They have discovered a way to predict and prevent particle leakage using symmetry theory. Instead of brute force calculations, it's like finding a secret passage through a maze that you have been trying to solve for many decades, a breakthrough that makes designing fusion reactors 10 times faster and could cut years off development time in a very fierce and global competition. In Germany, the Wendelstein 7X stellarator reactor has just demonstrated it can match the performance of much larger tokamak reactors. A stellarator is like a tokamak, twisted into a twisted donut shape. And although harder to build, they can run continuously instead of in pulses. The German team achieved what is called the BA product, a measure of temperature, density, and confinement time, putting them on par with the best tokamaks in the world. They did this with a reactor that looks like modern art, more than a machine. Meanwhile, at the Lawrence Livermore National Laboratory, the National Ignition Facility continues to break its own record. They use a completely different approach, firing 192 laser beams at a small fusion fuel pellet. Last December, they achieved ignition, producing more energy from fusion than the energy the lasers supplied to the target. They have repeated this feat many times, with one shot producing 3.15 megajoules from only 2.05 megajoules of laser energy. It's like lighting a match and turning it into a bonfire. But this is where things get really interesting. A company called Helion is taking a completely different approach. Instead of trying to contain superhot plasma in magnetic fields or crushing pellets with lasers, they are accelerating two plasma rings towards each other at 1,000 miles per hour. And when they collide, the impact creates fusion conditions in just a tiny fraction of a second. But that is enough, they claim, to harvest energy directly as electricity without needing steam turbines. If it works, it could make fusion power plants as simple as solar farms, with implications far beyond clean energy. Fusion reactors produce helium-3, a rare isotope so rare that currently it costs $30,000 per liter on Earth. Helium-3 could enable a generation of quantum computers, new medical imaging devices, and even fusion rockets. For deep space exploration, a fusion power plant could produce enough helium-3 to supply the current global demand while generating electricity. It's like discovering your car can produce gold as a waste product. Private capital is pouring into fusion at an unprecedented rate. Over $7 billion has been invested in fusion startups, with companies like TI Technologies, General Fusion, and First Light Fusion all claiming they will achieve commercial fusion before 2035. These are not wide-eyed dreamers. These are teams including former space engineers, Nobel laureates, and veterans from the semiconductor industry. They are applying Silicon Valley's rapid iteration speed to a problem government labs have studied for 75 years. The race has geopolitical implications that overshadow even quantum computing. China is building a fusion reactor called EAST, recently maintaining plasma for 1/606 seconds. They plan to have a demonstration power plant operating by 2035. The European Union is building ITER, the largest fusion reactor ever constructed, although it has been hampered by delays and cost overruns. Japan has achieved 360 million degrees. In their JT60SA reactor, every major power knows that whoever Masters Fusion First will basically have unlimited clean energy. Think about the implications of unlimited clean energy. We could desalinate seawater to irrigate deserts. We could pull carbon dioxide directly from the atmosphere and turn it back into fuel. We can provide energy for vertical farms producing food anywhere. Regardless of the climate, we can make aluminium and steel. Without any carbon emissions, every energy-intensive process currently relying on fossil fuels can be replaced. The entire global economy can be restructured around abundant, clean energy. Fusion fuel is almost ridiculously abundant. Sodium can be extracted from seawater, and there is enough in the oceans to power humanity. For billions of years, tritium can be produced from lithium, a common element in the Earth's crust, a fusion power plant, the size of a conventional coal plant, can power a city of 1,000 people using only a few kilograms of fuel per day. No mining, no pipelines, no oil tankers, just water and lithium, producing the same energy that powers the stars. We are also seeing unexpected breakthroughs in fusion physics. Researchers at MIT discovered that adding a small amount of beryllium to plasma can increase fusion rates by 50%. It's like discovering that a pinch of salt can make your car engine twice as efficient. At Princeton, scientists have found ways to use machine learning to predict and prevent disruptions, that is, sudden loss of plasma confinement, which can damage the reactor. AI can recognize patterns in plasma behavior that humans have never noticed, preventing millisecond problems before they occur. The timeline continues to accelerate. In 2010, experts said, commercial fusion was 55 years away. In 2015, they said 35 now. By 2025, many companies are promising demonstration plants within 15 years. The UK government is confident enough to be selecting sites for plants. Commercial fusion expected to operate by 2040. Canada has created a legal framework dedicated to fusion energy. Infrastructure for a fusion-powered world is being built before the technology is proven, but perhaps the most remarkable thing about fusion is how it could transform our relationship with energy itself. Throughout human history, we have been limited by energy scarcity. Wars have been fought over, oil economies have collapsed due to energy shocks, and billions still lack reliable electricity. Fusion could end that chapter of human history. Energy could become so abundant and cheap that we stop thinking about it. Like air or sunlight. Imagine a world where energy, poverty, is impossible, where we can solve any problem. Simply by applying more clean energy to it, that world could be just 15 years away. Biology and genetics, reversing aging, progress with CRISPR. In a laboratory at Stanford University, something happened last month. That sounds like pure science fiction. Scientists took brain cells from old mice, that is, cells that had basically given up on dividing and regenerating, and made them young again. Not just healthier, not just more active, but actually young at the molecular level. The mice showed a 30% increase in lifespan, and their cognitive function returned to levels seen in mice only a fraction of their age. If this works in humans, and early trials suggest it might, we could be looking at adding tens of healthy years to human lifespan. The tool making this possible is CRISPR-Cas9, a gene editing technology that won the Nobel Prize just a few years ago, but has advanced so rapidly that those initial achievements now seem primitive. Think of CRISPR as molecular scissors that can cut DNA at exactly the right spot, combined with a GPS system. Such molecular scissors can cut DNA at the exact position combined with GPS systems, guiding those scissors to precise moving addresses. But what scientists did in 2025 goes far beyond cutting and pasting. Simply, they are using CRISPR to orchestrate a symphony of genetic changes that reverse aging. A breakthrough when researchers identified a gene called SLC20A4, a gene controlling glucose transport in brain cells. As we age, this gene becomes overactive, flooding our neurons with sugar and basically caramelizing them from the inside. By using CRISPR to reduce this single gene, scientists have restored youthful function to essentially aged brain cells. Old neurons begin dividing again, forming new connections, creating fresh memories. It's like taking a computer from the 1980s and upgrading it to modern specifications, except we're doing this with living tissue. But brain rejuvenation is just the beginning at Harvard Medical School. George Church's lab has identified 25 longevity genes, which, when properly activated, can extend lifespan in mice by up to 50%. They are not just making mice live longer. They are making them live better. These genetically modified mice maintain muscle mass, bone density, and immune function until the years that would normally be their end of life. Essentially, they are aging at half the rate. And Church predicts this technology could be ready for human trials within 5 years. The approach they are taking is revolutionary. Instead of trying to fix thousands of defects that occur with aging, they are targeting master switches that control the aging process. One of these switches involves something called Yamanaka factors, 4 genes that can reprogram mature cells back to an embryonic state. The trick is to activate these factors just enough to rejuvenate cells, without turning them into stem cells or causing cancer. It's like rewinding a car's odometer, without dismantling it. Teams at the Salk Institute have demonstrated partial reprogramming in living animals, with astonishing results. Progeria mice, a disease causing rapid aging, lived 30% longer when treated, with periodic low doses of Yamanaka factors, but more importantly, their organs showed real signs of rejuvenation. Failing kidneys began functioning again, hearts pumped more efficiently, and even their skin became more elastic. These mice not only lived longer, they were younger. The rate of progress is spectacular. Just 5 years ago, precisely editing a single gene was considered a major achievement. Now, scientists at UC Berkeley are editing tens of genes, simultaneously orchestrating complex migration programs that seemed impossible in 2010. They are using new variants of CRISPR, like prime editing and base editing, which can change single DNA letters without cutting the double helix. It's like going from a sledgehammer to a laser. Surgery. One of the most promising developments involves targeting senescent cells, that is, zombie cells that accumulate as we age. These cells have stopped dividing but refuse to die, releasing inflammatory chemicals that damage surrounding tissue. Researchers at Mayo Clinic have developed senolytic therapies targeting and removing these cells. Notably, mice treated with these senolytics showed improved kidney function, increased endurance when running, and even hair regrowth. Human trials have been conducted for conditions like osteoarthritis and pulmonary fibrosis. The implications for specific diseases are astounding. Alzheimer's, a disease affecting millions worldwide, could be prevented by editing just a few genes. Scientists have identified genetic variants that make some people nearly immune to Alzheimer's, and CRISPR could provide everyone with these protective mutations. Similarly, genes affecting cholesterol metabolism, blood pressure regulation, and inflammation could be edited to prevent heart disease. Before it begins, we are talking about not just treating diseases, but the technique of immunizing against them. Private companies are racing to commercialize these technologies. Antos Labs, supported by billions of dollars in funding, has recruited some of the world's leading aging researchers to develop cellular reprogramming therapies. Calico, the Google longevity company, is using artificial intelligence to identify new longevity targets for CRISPR editing. A startup called Rejuvenate Bio has been testing gene therapies that reverse aging in dogs, with human trials planned for 2027. But perhaps the most exciting development is the discovery that aging may not be inevitable. As we once thought, researchers studying supercentenarians, those who live past 110 years, have found that many carry unique gene variants that seem to slow or even reverse aspects of aging. A woman in France who lived to 122 years old had the cardiovascular system of someone in their 60s, and CRISPR could potentially provide everyone with these super longevity genes. The ethical implications are profound and urgent. If we can extend human lifespan by decades, or even centuries, AI will have access to these treatments. How will society function if people routinely live to 150 years old? What will happen to concepts like retirement inheritance or even marriage if death becomes a distant prospect? Rather than an imminent certainty, these are no longer hypothetical questions. They are challenges we need to address within the next 15 years. Some researchers go even further, arguing that aging itself should be classified as a disease. David Sinclair at Harvard argues that aging is not a natural process but a disorder that can be treated and cured. His lab has shown that the information for youth remains present in old cells. It just needs to be reactivated using a combination of CRISPR and chemical compounds. They have restored sight in blind mice and reversed paralysis in mice with optic nerve damage. The convergence of CRISPR with other technologies is accelerating everything. Artificial intelligence can now predict how genetic changes will affect lifespan with remarkable accuracy. Quantum computers, as mentioned earlier, can simulate aging processes at the molecular level, identifying intervention points we never knew existed. Nanotechnology can deliver CRISPR components directly to specific cells, editing our genome from the inside out. We are approaching what some scientists call the escape velocity of lifespan, the point at which we can extend life faster than we age. If we can add more than 1 year of lifespan for every year that passes, death will become optional rather than inevitable. This may sound like science fiction, but consider that human lifespan has doubled in the past 200 years. The difference now is we are not just treating symptoms or preventing disease, but hacking the source code of life itself. The first person to live to 150 may already be alive today. They may be listening to this right now. The question is not whether we can beat aging, but whether we are ready for a world where we have done so, because make no mistake, the ability to edit our own genes to reverse aging at will is essentially becoming different versions of ourselves, representing a profound transformation of the human condition, like the development of language or the discovery of fire. We are on the brink of controlling our own evolution, and the decisions we make in the coming years will resonate through centuries, perhaps millennia to come. Chapter 7. Medicine and Neuroscience Advances in Brain-Computer Interfaces. A paralyzed man in Switzerland just typed a message using his thoughts at a speed of 90 characters per minute, nearly as fast as you can text on a phone. Another patient controlled a robotic arm so precisely that she could lift a cup of coffee and drink from it, something she had not been able to do with her own arm. In 15 years, these are not touching stories from a distant future. They are happening right now in 2025 and are just the beginning of a revolution that will fundamentally change the meaning of being. Human Precision Neuroscience, founded by former Neuralink executives, has just announced results from their first human trials that have shaken the neuroscience community. Brain-cortex interface. Their layer 7 is a membrane thinner than a human hair lying on the brain's surface, reading electromagnetic signals from thousands of neurons simultaneously, unlike other brain implants, requiring drilling through the skull. This device can be inserted through a clean incision smaller than a grain of rice. The whole process takes less than 20 minutes, and the implant can be easily removed. What makes this breakthrough remarkable is not just the technology, but what the technology has revealed about consciousness. When researchers analyzed brain signals from these implants, they discovered something that challenges everything we thought we knew about how consciousness works. The brain does not generate consciousness like a computer generates calculations. Instead, consciousness seems to emerge from the interaction between brain and body, especially from something called interoception, that is our perception of internal bodily signals. Think about this for a moment. The feeling that you are you, the consciousness of yourself, may not originate from your brain at all. New research from the University of Sussex shows conscious experience begins with the brain interpreting signals from the heart, gut, breath, Even your skin temperature, the brain constantly predicts what these signals will be like. And when reality does not match the prediction, consciousness arises from that mismatch. It's as if consciousness is the error-correcting mechanism of existence itself. This discovery is changing how we treat disorders. Consciousness patients in a vegetative state with no behavioral signs of awareness have been connected to brain-computer interfaces, and something extraordinary happened. Many of them were actually conscious, trapped in bodies unable to respond. Using these interfaces, they could answer questions, express preferences, and even communicate with loved ones. For the first time in years, a patient, unresponsive for 7 years, used the interface to tell his family he was not in pain and wanted to keep living. Another requested to listen to his favorite band. Desires for mental health are no less profound. Depression, anxiety, PTSD, post-traumatic stress disorder. These conditions are all linked to disrupted brain activity patterns, which we can now see and potentially adjust in real time. Researchers at Johns Hopkins are using brain-computer interfaces to detect neurological signs of depression before patients realize they are slipping into a depressive episode, then can stimulate specific brain regions. To prevent depression from occurring, it's like having a pacemaker for your mood, but technology is advancing so fast that we have moved on to applications beyond medicine. At the University of California, researchers have created a brain-to-brain interface allowing 3 players to play Tetris together using only their thoughts. One person can see the game screen. While the other 2 see the falling blocks, they must coordinate their thoughts to rotate and place the pieces accurately. They achieved an 85% success rate, proving that we can create a telepathic link, a functional connection between human minds. Military applications are causing both excitement. DARPA is developing neural interfaces, allowing soldiers to control swarms of drones. Just by thinking or silent communication on the battlefield, pilots can fly planes at the speed of thought, making decisions faster than any enemy can react. But this raises frightening questions about the future of warfare. If we can control machines with our minds, could those machines control us back? Could enemies hack into a soldier's brain interface and turn them against their own forces? Commercial applications are arriving faster than any AI expected. Meta is developing non-invasive brain interfaces that can detect the words you are thinking before you say them. Imagine messaging without touching your phone or translating your thoughts directly into any language. Apple has patented brain interfaces that could allow you to control your entire digital life. Just by thinking, we are approaching a world where the boundary between mind and machine not only blurs but disappears completely. The strangest discoveries come from studies on anesthesia and psychedelics. When patients under anesthesia are monitored with advanced brain interfaces, we can see consciousness flickering on and off like a candle flame. But here is the strange part. Sometimes consciousness persists. In forms we do not recognize, patients report vivid experiences. Throughout the time, their brains show no activity in regions we think are necessary for consciousness. It's as if consciousness can exist in ways that current science cannot explain. Research on psychedelics is revealing more mysteries as people use substances like psilocybin or DMT. While connected to brain interfaces, their neural activity becomes more random, more chaotic, yet they report experiences of clarity and profound meaning. The default mode network, which is the brain system related to our sense of self, basically dissolves. People report conscious experiences without a self, awareness without an ego. These states can show us what consciousness looks like when stripped of the ego being the narrative self we often mistake for who we are. The philosophical implications are staggering. If consciousness arises from brain-body interaction, rather than just the brain, then artificial intelligence may never have consciousness in our way, no matter how intelligent it becomes. But that also means we could create new forms of consciousness. By altering these interactions, some researchers have experimented with artificial interoception, providing AI systems with simulated bodily signals to see if something like consciousness emerges. We are also discovering that consciousness may not be binary, meaning on or off, but exist on a spectrum with many levels and types. Locked-in patients exhibit one kind of consciousness, dreamers another. Meditators, yet another. Brain interfaces are revealing that even in healthy awake people, different parts of the brain can have different levels of consciousness simultaneously. Your visual cortex may have high consciousness, while your motor cortex operates unconsciously all at the same moment. The most controversial research involves enhancing normal human consciousness. Scientists at MIT have shown that electrical stimulation of specific brain areas can temporarily increase IQ by up to 20%, enhance creativity, or even produce math abilities like a prodigy. Professional gamers have been using transcranial direct current stimulation to improve their reaction times. Students are using it to boost memory formation. Students are using it to enhance memory formation. We are approaching a world where cognitive enhancement through brain stimulation could become as common as coffee. Some researchers are going even further, suggesting brain interfaces could allow us to experience entirely new forms of consciousness. Imagine having direct sensory experiences of magnetic fields like birds do, or seeing infrared rays like snakes. We have the ability to directly upload skills into our brains in a matrix-like fashion, or share memories and experiences between individuals. The boundary between self and others, between individual consciousness and collective awareness, could become voluntary rather than fixed. But perhaps the most profound discovery is that consciousness itself may be a fundamental feature of the universe rather than an emergent property of the complex brain. This theory is called panpsychism, suggesting that everything from electrons to galaxies has some form of experience or awareness. Brain interfaces may not detect consciousness as much as tune into it like a radio picking up signals that has always been there. If this is true, then death may not be the end of consciousness, but simply a transformation into another form of awareness. Chapter 8. Psychology and Behavior. The Mystery of Mind Control and Memory. Your brain is lying to you right now, not in some metaphorical sense, but actually creating false memories that alter your perception and rewriting your past experiences in real time. Scientists at McGill University recently published research showing that gaslighting, the psychological manipulation technique, is genuinely effective because our brains are designed to be reprogrammed by social input. What we call reality is actually just a consensual illusion that can be hacked by any AI that understands the code. This discovery comes from studying people in controlled gaslighting experiments where researchers deliberately provide participants with false information about events they witnessed. Brain scans reveal a shocking fact when a trusted friend tells you something happened differently from what you remember. Your brain not only doubts your memory but actually rewrites it. The hippocampus, where memories are stored, shows activation patterns. Similar to when forming new memories, your brain is editing your past to match what you are being told. This is not a flaw in human consciousness. It is a feature our brains evolved to prioritize social cohesion over objective truth, because for most of human history, being expelled from the group meant death. So when the group says the berries are poisonous even though you remember them as safe, your brain updates your memory to match the consensus. By 2025, this mechanism is being exploited by social media algorithms, political propaganda, and even marketing campaigns that can literally change your memories of products you have used. But here is where things get really strange. Researchers at UC San Francisco have discovered that memories are not only socially malleable, they can be completely fabricated using a technique called optogenetics. By stimulating specific neurons with light, scientists can implant entirely false memories into mice. The mice actually remember events that never happened, showing fear responses and behavioral patterns, as if the events were real. Human experiments are clearly prohibited for ethical reasons, but the mechanism appears identical in the human brain. Even more worryingly, a study published last week shows that fatty fast food can hijack your memory system in just 4 days. Scientists fed mice a diet similar to what many Americans eat daily, high in fat and processed sugar, and observed their hippocampal neurons becoming hyperactive. Can hijack your memory system in just 4 days. Scientists fed mice a diet similar to what many Americans eat daily, high fat and processed sugar, and observed their hippocampal neurons becoming overactive. The mice lost the ability to properly form new memories and showed signs of confusion about recent events. Researchers restored normal glucocerebroside levels, neurons calmed down, and memory function returned. Your diet is literally editing your actual memory ability accurately. Cashmere for conditions like Alzheimer's is revolutionary. We once thought memory loss and dementia was like files deleted from a hard drive, but new research shows memories are still there. We just can't access them. Scientists at MIT have successfully restored lost memories in mice with Alzheimer's by using light to stimulate specific neural pathways. Memories don't disappear, they are just disconnected. Human trials using focused ultrasound to achieve similar effects are showing promising initial results, but memory is only the beginning of psychological mysteries. That we are uncovering morning sickness means the distressing experience of pregnancy, affecting 70% of pregnant women, turns out to be a sophisticated evolutionary defense system. UCLA researchers discovered that nausea is not random. It is a precisely tuned biological program to protect the fetus, developing from potentially harmful foods. The timing, intensity, and specific triggers of morning sickness correspond to critical stages of development. Fetal organs women experiencing moderate morning sickness actually have lower rates of miscarriage and birth defects. This mechanism is very appealing. When a woman is pregnant, her immune system begins to identify foods that may contain pathogens or toxins harmful to the developing baby. Then it triggers nausea, especially towards those foods, creating aversions that can last throughout pregnancy. It is so sophisticated it can distinguish between similar foods based on tiny chemical differences. This is evolution programming behavior through physical discomfort using the mother's body as a chemical detection system for the baby, talking about evolution shaping behavior. Researchers have made a shocking discovery about autism instead of being a disorder or error. Autism seems linked to rapid evolution of brain regions. Characteristic of humans, it is these genes that have given humans our exceptional cognitive abilities, the ability to think abstractly. Complex language and technological innovation are associated with autism genes. Essentially, autism may be the price we pay for the evolutionary advances that made us human. Studies of autistic individuals show they often have enhanced abilities in pattern recognition, system thinking, and attention to detail. These traits would have been extremely valuable in societies of early humans for tasks like tracking animals, identifying edible plants, or making tools. The prevalence of autism has remained stable throughout human history, indicating it is not a disease to be eliminated, but a variant that provides advantages for the entire species. Silicon Valley has an unusually high rate of autism, and that is probably no coincidence. That is where those cognitive differences are most valued. How our brains process social information is also being completely rewired. A large brain imaging study has found that loneliness literally changes the structure of your brain. Lonely people have different white matter patterns, that is, the neural highways connecting brain regions. Their default mode network, the system active, when we are not focused on the outside world, is overactive. They also show increased activity in areas related to vigilance and threat detection. Loneliness doesn't just feel bad. It fundamentally restructures your brain to survive in isolation. But the most worrying findings relate to free will, or rather its absence. Neuroscientists can now predict, with 80% accuracy, whether you will choose to move your right or left hand up to 10 seconds before you think you have made the decision. The conscious experience of choice seems to be a narrative told after the fact, that your brain creates to explain decisions made by unconscious processes. Your brain decides before you become aware of the decision. Then you create a story about why you made that decision. Free will may be the ultimate illusion, which has profound implications for criminal justice, mental health treatment, and personal responsibility if our decisions are made unconsciously before we become aware of them. Are we truly responsible for our actions? Some courts have, and are considering neuroscientific evidence in sentencing, recognizing that injury or abnormality may remove what we usually consider free choice. We are approaching a future where brain scans may be more important than testimony in determining guilt or innocence. Behavioral manipulation through environmental cues is reaching a frighteningly sophisticated level. Casinos have long known that certain sounds, lights, and patterns can trigger compulsive gambling behavior, but new research shows behavior can be precisely controlled by analyzing millions of data points from online behavior. AI systems can now predict with 93% accuracy whether an AI user will make a purchase, click a link, or even fall into depression. We are not just being tracked online, we are being programmed. The scariest part is how subtle the manipulation can be. Researchers have found that showing people certain colors for just 30 milliseconds, too fast for conscious perception, can change their mood and decision-making ability for hours afterwards. Music played in stores is carefully chosen to alter your walking speed and increase the likelihood of purchases. Even temperature and humidity in shopping environments are optimized to put you in a buying mood. Your environment is constantly programming your behavior below the threshold of awareness. But there is hope. Understanding these mechanisms gives us the power to resist them. Meditation has been proven to strengthen the prefrontal cortex, the brain region involved in conscious control and decision-making. Regular meditators are less easily manipulated and show greater activation in brain areas related to free will, if such a thing exists. Knowledge itself becomes a form of protection. Once you know how your brain is hacked, you can begin to build defenses. In conclusion, our cosmic moment. As we drift through these final moments together, let us reflect on what we have witnessed tonight. A visitor hiding behind our sun. Something that could reshape how we understand our place in the universe. 6,000 worlds orbit distant stars. Each world a mystery waiting to be solved. The promise of unlimited clean energy from fusion. Finally, within our reach. The ability to edit. Our own genetic code to reverse aging. Machines that can read our thoughts. And perhaps soon share our consciousness. The disturbing realization that our memories can be rewritten, our behavior programmed, our reality manipulated phenomena, unexplained in our skies that governments can no longer ignore, and a climate system pushed to breaking points we did not know existed. These are not separate stories. They are chapters in the same cosmic story, the story of a species on the brink of transformation. We stand at the threshold between what we have been and what we might become. The decisions we make in the coming years, about how we use CRISPR, how we merge with artificial intelligence, how we respond to climate change, whether we reach for the stars or retreat into ourselves. These decisions will echo through the centuries. Perhaps a millennia-old thought about where you are listening tonight. Perhaps in bed letting these mysteries drift as you fall asleep. Maybe on a long journey watching the stars spin overhead as you contemplate our place among them, or maybe just doing your daily work. But now carry with you the knowledge that we are living in an extraordinary era, the most extraordinary in human history, an era where the impossible becomes possible so frequently that we hardly stop to marvel at it. The universe has patiently kept its secrets for billions of years. But now, in this brief cosmic moment, which we call the 21st century, those secrets are revealing themselves at a spectacular pace. We are the generation that will witness first contact or confirm that we are alone. We will cure aging or accept mortality. We will save our planet. or witness it transform into something unrecognizable. We will merge with our machines or preserve our biological legacy. These are not far-fetched possibilities for future generations. These are the choices we are making right now, as consciousness itself becomes something we can measure, manipulate, and perhaps create. We must face the deepest question, the meaning of awareness in a universe that itself may be conscious. Every discovery we have discussed tonight brings us closer to that ultimate mystery. Are we the universe knowing itself? Are we alone in that awareness? And if we are not, what responsibility comes with that knowledge? Thank you for joining me on this journey across the frontiers of human knowledge. If these discoveries have sparked your curiosity, stirred your imagination, or even unsettled your comfortable assumptions about reality, please consider sharing this with someone who might appreciate wrestling with these profound questions. Hit the like button if you want to see more in-depth videos about the science reshaping our world, and subscribe with notifications on so you don't miss the next revelation. Because at the pace things are happening, tomorrow's discoveries may render everything we discussed tonight obsolete. Remember that everything discussed tonight represents our best current understanding, based on available evidence and peer-reviewed research. Science is a continuous process of discovery and revision. What seems certain today may be overturned tomorrow by new evidence. That is not a weakness of science. It is its greatest strength. Stay curious, stay skeptical, and never stop asking questions. Until next time, as you fall asleep tonight, remember you were made from star matter, living on a tiny world, orbiting an ordinary star in an unremarkable galaxy among thousands of billions of galaxies. Yet somehow, despite all odds, you are here, you are aware, and you are part of the greatest story ever told, the universe understanding itself. Wishing you sweet dreams and good night.